Welcome to Cambridge IGCSE Physics, Lesson 12.1, Work Done. Today we explore one of the fundamental concepts in physics, the relationship between work done and energy transfer. This lesson forms part of the core content for Cambridge IGCSE Physics Specification 0625. We will examine how forces acting through distances transfer energy and learn to calculate work done using the equation W equals Fd. Understanding work done is essential for analysing energy transformations in mechanical systems and forms the foundation for more advanced physics concepts. Let's examine our learning objectives for today. By the end of this lesson, you will be able to first, understand that work done equals energy transferred. This fundamental principle connects force and motion to energy concepts. Second, recall and use the equation W equals Fd equals delta E. Here W represents work done, F is force, D is distance, and delta E is energy transferred. Third, calculate work done by a force in various situations. These objectives align with Cambridge IGCSE assessment objectives. AO1 tests your knowledge of concepts, AO2 evaluates calculation skills, and AO3 assesses your ability to analyse physical situations. Now let's define our key vocabulary. Each term is essential for understanding this lesson. First, work done, which means energy transferred when a force acts through a distance. Work done is measured in joules, symbol J. Second, force, which means a push, or pull acting on an object. Force is measured in newtons, symbol N, named after scientist Isaac Newton. Third, energy transferred, which means the change in energy of a system when work is done. Energy is also measured in joules. Understanding these terms precisely is crucial. Remember to use SI units, the International System of Units, throughout all calculations, and always include proper scientific notation. Let's explore our first core concept. The fundamental principle states that work done equals energy transferred. This means when a force acts on an object and causes it to move, energy is transferred to or from the object. The definition is, work is done when a force moves through a distance. Both force and movement must occur for work to be done. Mathematically, we express this as W equals F times D equals delta E, where W represents work done measured in joules, F represents force measured in newtons, and D represents distance measured in meters. The diagram illustrates this concept. A force F acts on an object, causing it to move through distance D. Notice how the force and motion are in the same direction. This principle is fundamental because it connects mechanics with energy, forming the basis for understanding all energy transformations. Now we examine the experimental method for measuring work done. This follows Cambridge IGCSE standards. The apparatus needed includes a Newton meter to measure force, a ruler to measure distance, an object to move, and a smooth surface to reduce friction. The method consists of these steps. First, attach the Newton meter to the object using string. Second, pull the object with constant force, reading the force from the Newton meter. Third, measure the distance moved using the ruler. Safety is paramount. The hazards include apparatus falling or sudden movements causing injury. Therefore, you must secure all apparatus and avoid jerky movements. The diagram shows the experimental setup. Newton meter connected to object on smooth surface with ruler below. Notice how the force is applied horizontally and parallel to the motion direction. Let's work through our first example. The problem states, a force of 20 newtons moves an object 5.0 meters. Calculate the work done. We are given force F equals 20 newtons, distance D equals 5.0 meters. We need to find work done. W step 1, write the equation. We use the work equation, which is W equals F times D, where W is work done in joules, F is force in newtons, and D is distance in meters. Step 2. Substitute the values. We write W equals 20 newtons times 5.0 meters. Step 3. Calculate. 20 times 5.0 equals 100. Step 4. State the answer. The result is 100 joules to 3 significant figures, since 1 Newton meter equals 1 joule by definition. Example 2 applies the same principle differently. The problem is, an object gains 150 joules of kinetic energy. Find the force if the object moved 12 meters. The data shows change in energy delta. E equals 150 joules, distance d equals 12 meters. Now we analyze. First, use the relationship W equals delta E. Since work done equals energy transferred, the work done is 150 joules. Second, apply the work equation. We use W equals F times D, substituting 150 joules equals F times 12 meters. Third, rearrange to find force. F equals 150 joules divided by 12 meters. Fourth, calculate the result. 150 divided by 12 equals 12.5 newtons. The diagram shows energy transfer. Initially 0 kinetic energy, work is done. Finally 150 joules kinetic energy. Mathematical skills are crucial in physics. Let's examine 3 key skills. First, equation rearrangement. When we need to find a different variable, we rearrange algebraically, starting with W equals F times D, where W is work done, F is force, and D is distance. To find force F, we divide both sides by D, giving F equals W divided by D. To find distance D, we divide both sides by F, giving D equals W divided by F. Second, unit conversion. To convert from kilometers to meters, we multiply by 1,000, since 1 kilometer equals 1,000 meters. To convert centimeters to meters, we divide by 100, since 100 centimeters equals 1 meter. Third, significant figures. The precision of your answer should match the least precise measurement in the data. This maintains mathematical accuracy and reflects measurement limitations. Now practice what you've learned with these 3 questions. Question 1 is basic level. It asks, a force of 15 newtons moves an object 8.0 meters. Find the work done. This tests direct application of the work equation. Question 2 is intermediate. It states, work done is 240 joules, distance is 16 meters. Find the force. This requires you to rearrange the equation to solve for force. Question 3 is advanced. The question is, an object is lifted 2.0 meters and gains 98 joules of potential energy. Find the weight. This tests your understanding that work done against gravity equals change in potential energy, and weight is the gravitational force. For all questions, remember to show you're working clearly, include units in every step, and check your answers make physical sense. Write your answers now before looking at the solutions. Physics principles power our modern world. Let's see how today's concepts apply in practice. In engineering, cranes must calculate work done to lift heavy loads safely. Engineers use W equals F times D to determine power requirements and ensure structural integrity. The force is the weight of the load, distance is the height lifted, and work done determines energy needed. In sports science, athletes optimize work done for peak performance. Weightlifters, jumpers, and runners all apply force through distance. Understanding work done helps coaches improve training efficiency and prevent injury. In renewable energy, wind turbines convert kinetic energy of moving air into electrical energy. The work done by wind on turbine blades generates the rotation that produces electricity. These applications show why physics matters. Career-wise, physics knowledge leads to mechanical engineering designing machines, sports science optimizing human performance, and the energy sector developing sustainable technologies. Let's review the solutions. For question 1, the answer is W equals F times D equals 15 newtons times 8.0 meters equals 120 joules. This is correct because we applied the work equation directly with the given values. For question 2, we rearrange to find force. F equals W divided by D equals 240 joules divided by 16 meters equals 15 newtons. The units work out correctly since joules divided by meters gives newtons. For question 3, we recognize that work done against gravity equals change in potential energy. So weight equals delta PE divided by height equals 98 joules divided by 2.0 meters equals 49 newtons. This is reasonable for a medium-sized object. Now, exam success tips. First, always show you're working. Even if the final answer is wrong, you earn marks for correct method. Second, include units in every step of calculation. This prevents unit errors and shows understanding. Third, check if your answer is reasonable. If you calculate negative work for lifting an object, something is wrong. Fourth, read questions carefully. Command words tell you what to do. Calculate means find a numerical answer. Describe means state features. Explain means give reasons with scientific principles. Let's summarize today's lesson. The key points to remember are: first, the fundamental principle that work done equals energy transferred, expressed as WD equals delta E. This connects force and motion to energy. Concepts showing that when forces act through distances, energy changes occur in the system. Second, the key equation W equals F times D, where W is work done in joules, F is force in newtons, and D is distance in meters. This equation applies when force is constant and parallel to motion direction. Third, correct units are essential. Work is measured in joules, force in newtons, and distance in meters. 1 Newton meter equals 1 joule by definition. These three concepts form the foundation for understanding energy transfer in mechanical systems. For further study, practice equation rearrangements to solve for different variables. Master unit conversions between different length units. The next lesson covers power, which builds on today's work by examining the rate of energy transfer. Ensure you understand work done before moving forward, as power equals work done divided by time taken.